not like specific, then that you can tell. Something additional you want to inform, tell the people.
Yeah,
Okay,
I
so
mean,
I think we'll wait. The participant has any doubt or more students join. So, sir, how was it over last 2 3 weeks? I mean, did they ask doubts or?
No, last week, other week, I they were asking question and I was trying to explain. Last week, what I because in that one most of the people asked about accelerator applications. So
Okay.
I prepared a lecture
Mm-hmm.
telling about the various applications. I
Mm-hmm.
did
Okay.
not explain much, but I gave some glimpses of the latest applications which are, although some of them are already covered. For example, in your lecture, ADS
Mm.
you have covered, plus the
Okay.
physics part later on. One more lecture was there, so they are covered. But some of the applications which are not covered in very detail, so that I try to. It was a repeat basically.
Okay. So far, I think four of my lectures have been covered. So, so again, any doubts? Then otherwise, only one student is there. So
yeah,
I
One student and three teachers.
yeah.
I'm not a
Okay,
teacher.
maybe the student can respond. I mean, any doubts or we can maybe you can give feedback about whatever you've learned.
So, Abu Bakar, if you have any doubts, yeah, you can ask ma'am or sir.
Good evening, sir and ma'am.
Yeah.
I don't have any doubt as such, but
Oh,
I joined first time
okay,
just
okay.
to see what is going on. If anything knowledgeable is there, then I can get benefit. So I joined. Can you hear me, sir?
Yeah, your voice is little unclear, but yeah, I understood you have no doubt, right?
I don't have any doubt as such.
Okay.
I joined first time
Yeah, yeah,
this
yeah.
session.
No, but you are
Just
going
to,
through the lectures, right, on the NPTL?
yeah. Sir. That's good, sir. Lectures are very good.
Okay. So,
Okay.
so far you understood everything in the lectures.
Actually,
So you don't have
I
to be.
mean,
You can ask anything if you don't understood anything, any
So
topic.
what about the assignments? I mean, did you
Yeah.
face any difficulty in doing the
No,
assignments?
I think you can ask what is happening to Chandrayaan.
Yeah, that
I'm
also.
more interested what happened to Chandrayaan 2 just before the landing. What was the failure? I just meet ISRO scientist yesterday. I asked the same question to him yesterday, but whatever he replied, I didn't get. So if you can describe it more, what happened to Chandrayaan 2 just before the landing? What was the actual
Again,
physics?
no, I don't think we are experts on that. I think we should limit ourselves to accelerator physics. So if you have anything in
Okay.
accelerator physics, let me address that. So I mean, the ISRO scientists are the best people to answer that question. We are not experts.
Yeah, but you can ask anything from the lectures.
From the lecture, actually, I
Yeah.
also got the classes and the same discussion, whatever you discuss here, we discuss in the class along with the lectures. My teachers play the lectures. We have the separate period for this NPTL lecture, and our teachers start the video. And if we have any doubt, we discuss with them,
Okay.
and we solve the problems in the
Oh,
class.
that's fantastic.
Oh, that's nice.
I'm
May
a,
I ask
I'm a,
which college or where are you from?
Basically I'm from Saharanpur, Uttar Pradesh, but I'm studying in Chandigarh University, Chandigarh.
Oh, great. So the lectures are played in the class as a whole?
Not as a whole, but my teachers have the aspects to play the lectures. If we have any doubt in any section of the video, we tell him in this, and at that minute, at that second, we something is explained, but I didn't get. Then my teacher play the lecture and listen what are you saying, you are saying, and he explained it more deeply.
Okay.
And we also discussed about the accelerators, generally जो भी हमारे accelerators बने हैं या बनने जा रहे हैं.
So, what you are doing MSc or your bachelor's?
I'm MSc final year student.
Okay.
So can I ask you a question now?
Yes, sir.
This Chandigarh was going to set up a 6 million volt tandem accelerator. What is the status of that?
I don't know about that. I will ask to my teacher. Can you repeat the same thing again?
See, Chandigarh University was the physics department, actually physics department or maybe a separate department, I don't know. But they were going to set up a tandem accelerator 6 million volts.
Are you talking about Chandigarh University or the Punjab University? There are two universities.
They are different. I think it was.
Yeah.
Where was IM Govind?
No, I think you are discussing about Punjab University.
Acha, Punjab. Then maybe Punjab University, Chandigarh.
Ji.
Because initially Professor IM Govind proposed it, and then ultimately later on it was approved, and it was thought that it will be put in Chandigarh, a tandem accelerator with the 6 million volt terminal. I do not know, for quite some time I am not in touch with them now. So in fact I did not know that Punjab University is different from Chandigarh University.
Yes, sir. Different university.
Achha, that is separate. Okay, so it was Punjab University, Chandigarh.
Yeah, there are two universities. One is Chandigarh University in Punjab, and the other one is Punjab University in Chandigarh.
So there were, see, proposal was by Professor IM Govil and Professor HS Hans. I think they were in Punjab University.
Yeah.
So,
May I ask a general question to you?
Yeah. Sure.
Why जो गॉड पार्ट हिंदी मैं आज की हिंदी
Yeah, sure.
Yeah. You can.
जो ये गॉड पार्टिकल के लिए हमने अभी 2008 में शुरू किया था प्रोजेक्ट, और तो वो जो कोलिजन हुआ था तो उसमें हम गॉड पार्टिकल की खोज कर रहे हैं. तो ये मतलब करना क्या चाह रहे हैं एक्चुअली? हम नए पार्टिकल की खोज कर रहे हैं, उसको हमने गॉड पार्टिकल का नाम दिया है. व्हाट इज द मेन एम? मतलब क्या चाहते हैं? कि कहते हैं कि इससे बिग बैंग की के बारे में हमें पता चल जाएगा.
So maybe I should answer this because I'm working in this in LHC. So yeah, so I work in the CMS experiment from where this God particle was discovered in 2012. So you can understand English, right?
Yeah, I can understand.
Okay. So yeah, so the primary goal of the LHC was not just to discover Higgs boson or the God particle, but there are many other physics interests for which people are working there. So yeah, but I mean, so there is a standard model of particle physics, okay, and and it is the best theoretical model of the basic structure of universe that we have. And all other particles were found in other places, other accelerators. But to see a signal of Higgs boson, the God particle, we needed such kind of a large accelerator, and that's why scientists, that was the main motivation, I think, to build the LHC. And we did it, and we found the Higgs boson in both of the experiments, CMS and Atlas. Both reported it in 2012. And so now we have this complete standard model is now complete. All the particles in the standard model are experimentally found. But still, the standard model is not the whole picture. There are many assumptions in the standard model. There are many things which are not which are observed in the universe, which are not explained by the standard model, like dark matter and other things. So those things are also being explored in the LHC. There are many groups working for dark matter and exotic particles, supersymmetric particles like this. So yeah, these are the things. And also, not only we discovered Higgs boson, we discovered a very exotic state of matter called quark-gluon plasma by colliding two heavy nuclei. And that is where I work in. I mean, that is what my physics interest is, to study the properties of quark-gluon plasma. So when you collide two heavy nuclei at very high speed, around the speed of light, you create a fireball. Okay, it is like a mini Big Bang. It has the conditions which is similar to what we had in the Big Bang. Okay, and there this quark-gluon plasma state is observed, and after that the plasma cools down, and we get many particles in our detector, and then we do the reverse engineering, and we study the properties of that quark-gluon plasma matter using our detector. So yeah, many things are happening, and not just the God particle discovery was the but yeah. So maybe sir can add more.
No, I think the basic, in a layman's language, see, he asked that what is the aim? Aim is to understand the universe,
Yeah.
how the universe is formed, whether it is Big Bang or anything else. Then now, if you want to, now the basic thing is that Higgs boson, they bring all the mass of anything is because of Higgs boson. If there is no mass, that thing doesn't exist. So Higgs boson is primarily responsible for the masses of everything. So if universe is created, the mass is created. Mass is created, something has to be there, and that is this Higgs boson which brings the mass. So basically, basic aim of all this is to understand the universe, and to understand the universe, Higgs boson is required. It was proposed to be there, and then that has been discovered. That's the basic thing. Now I think nobody else is interested. So Rajni, you and me can leave.
Yeah, I think so. Because if there is any question, then okay. Otherwise,
Since Rohit said that he has to be there, so he can.
Yeah. I can stay, and I can discuss more with.
You can have a book and keep reading.
No, it's okay. I'll manage. Yeah, if you guys can leave maybe.
so once again, I would like to ask if there are any doubts or anything.
No, so Rajni, what you can do is you can leave it logged in, and maybe after 15-20 minutes or half an hour, you can again see if more people have joined. Then you can.
Okay, I'll also check in the chat box if there is any.
So you see in the chat box.
Yeah. Okay, I'll be around. I'll be checking. Okay.
And the contributors. So if there are more people have joined, then you can again ask after half an hour whether there are any questions.
That would be the best thing to do. So I'll check the chat box,
So
and
with your permission, Rohit, we can leave.
Yeah, sure. You don't need my permission.
Okay,
Sorry,
thanks.
Yes.
I'm around.
Okay.
Yeah, Rohit, I am around.
Yeah,
So,
sure, ma'am.
yeah, just my video and camera is off, and I'll come back.
Okay, ma'am, sure.
Okay.
Okay.
Thank you.
See you.
See you, sir.
Bye, sir.
So, hello, Abu. Uh,
Yes, sir.
so you got the point, right? Anything else like? So, what was your like original question? You can ask again.
सर इसके बारे में देखो हम मैं इनफॉर्मली पूछ लूँ सर?
हाँ हाँ जरूर जरूर.
अभी तो हम दो ही हैं सर.
नहीं नहीं कोई बात नहीं.
जी सर एक्चुअली मैं मेरा why we are concentrating on that highly मतलब बहुत ज़्यादा velocity के साथ वो जो collision होगा तो हम उसके हम why we are interested in that?
Okay, so you have studied.
Why that much
Energy.
that much speed is required?
Okay, let me explain. Okay, so you have studied some quantum mechanics, right? You know
Yes, sir.
de Broglie wavelength.
Yes sir, yes sir.
It is what it is, lambda equal to h by p, right?
Yes sir.
P is the momentum, right?
Yes sir, बिल्कुल.
No, momentum is what? Momentum is proportional to velocity.
Yes sir, बिल्कुल. Yes sir.
Yeah, so if a particle has a high momentum, what does it mean? Means it the Broglie wavelength is very small, right?
Yes sir.
Now, when we accelerate the protons at very high relativistic speed, okay, what will happen is, I mean, their de Broglie, first of all, when they collide, okay, when two protons collide, there are many things. I mean, it's a very complicated system. There are many things happening, but because there is too much energy, suppose a photon is created, okay,
Yes.
in the collision, anything can get created. Suppose a photon is created, that proton will have a very high momentum, and so its wavelength will be very small. And what it can do is it can go inside the protons, inside the quarks. It can interact with the quarks, okay, because it has a very small wavelength. Understand?
Yes,
If it has a large wavelength, it cannot probe a very small part of the proton, okay.
Yeah, that's the answer. Yes sir.
So you need a very high energy to get the information about the quarks. It is called the deep inelastic.
Find a fundamental particle.
Yeah, exactly. It's called the deep inelastic
maybe
scattering.
at a larger velocity collision जो उसके अंदर है जिसको हम अभी तक नहीं आइडेंटिफाई कर पाए, मे भी उनके रिएक्शन से या उनके आपस में मिलने से कुछ नया हमें शायद मिल जाए, ऐसा कुछ.
Exactly. So like I was mentioning, so how we search for the dark matter, okay. So suppose two protons collide, okay, and because in quantum mechanics anything can, in particle physics, so everything is like in you know quantum field theory. There is a concept called quantum field theory. So what does it means is all the fundamental particles are excitations of the quantum fields, okay. So when you collide the protons at such high energy, you perturb the quantum fields, okay. And maybe by chance you create a dark matter particle, okay, because dark matter is also a particle. It has its own quantum field, okay, fundamentally. So maybe you can create a dark matter or any supersymmetric particle. Anything can get created, right? Because your energy is so high, you are perturbing the quantum fields, okay. If you collide the two protons at just GeV velocities, you cannot probe that much inside the matter. It is not possible. So this high energy is very crucial. That's why it's called high energy physics, okay.
Sure.
So you can create a dark matter, and that will decay into ordinary matter, and then there are various methods to reconstruct the tracks of the particle, and you see a signal. You can get the mass of the particle that was created. Okay, and then you check with your standard model that what is the mass of the all the discovered particles. If it doesn't match with anyone, then you know that it's a new particle. Okay, so
Yes, sir.
yeah, these things are there. So it's very interesting if you think about
Yeah.
it. It's very
That's the
it's a-
same thing I discussed with my teacher,
Mhm.
and they replied the same. And but I was not that much satisfied, but now I'm satisfied. Very-
Yeah. And yeah, like I was also saying about the heavy ion collision. So that is also very interesting, because two protons, when two protons collide, it's just three quarks interacting with three quarks, right? So not much can happen there. But if you have two big nuclei, like we collide lead with lead in LHC, okay. So lead has how many neutrons and protons? Roughly 220 or something, right?
Okay, sir.
So 220 neutrons and protons colliding with 220 about neutrons, 224 I think. Okay, so that is a very big system, and all of them has and they are also colliding at TeV energies, teravolt energies. So you can imagine how much energy is getting deposited in a small volume of space, right? And so that collision of those two heavy nuclei create the condition which was exactly when there was exactly at the Big Bang. Okay, and so you can study Big Bang through those collisions. So that is what my group here in IIT Madras is working on. We try to study the properties of the matter created in these collisions, these heavy ion collisions, and yeah. So there are many interesting things that can be done with high energy.
LHC is a proton-proton collider, right?
No, in LHC we collide heavy ion also. It's called Large Hadron Collider, but we collide lead ion also at LHC.
But in 2012,
Yeah,
the
that
collision was
was
proton-proton.
that was the Higgs boson discovery was from proton-proton, because to get a signal of Higgs in lead collision, you cannot, because there are many backgrounds. Okay, in lead collision, like 10,000 particles get created after the collision, 10,000 of the order of 10,000 in each event, each collision. Okay, so to get a signal of a single particle from there, it's not possible. That's why you need a very small system like proton and proton colliding. There you can discover new particles. So different collisions have different uses, you can say. Different physics we can understand from different type of collisions.
In LHC, is it possible to collide neutron and neutron because they don't have charge?
No, you cannot collide neutron, because why you can't collide neutron? Can you answer?
Sorry?
Why you can't collide neutron? Neutron collision not possible. Why? Do you have any answer?
Because they don't have charge, so we cannot accelerate them.
Yeah, simple. I mean, it's neutral, right? You cannot bend it
Yeah.
in a magnetic field. You cannot accelerate it. So, yeah, neutron. But proton is.
Then how can we accelerate the neutron if we want?
You cannot accelerate neutron, but you have proton, right? Proton and neutron are just similar. Just the charge is not there on neutron, and three quarks are also there. Three quarks are here, so
Yeah.
it's not. You're not missing any physics by not colliding neutron. Okay,
But तो सर आज कह रहे हैं ना, but in future maybe if we will be able to accelerate neutron and we collide neutron and neutron, then maybe some new physics can be in there.
I
Could
don't
be.
know.
Could be.
I'm not sure how can you accelerate neutron. Do you have any idea?
Before 20-30 years, before maybe proton.
No, like
Well,
proton collision is always possible. I mean, We just didn't had the
Yeah,
experiment, but physically, like theoretically, it's possible, right? To accelerate proton and collide it, but theoretically, it's not. Whatever is not theoretically possible, how can you make it happen experimentally, right? Yeah, you can do one thing. So, as I mentioned, when the nucleus collide, uh, suppose when two nucleus collided, okay, what you get is, so suppose they are not colliding head on, okay, they collided off center. You understand? Hello.
I explain please. Option means
Off center means they are not. That's not a head on collision. It's
head-on
just,
collision. Okay, okay.
it touches like off center. Peripheral part. Just touch the
Okay.
peripheral part,
Yeah, yeah.
and so. But in that case, what will happen is the nucleus will get destroyed. Okay. Both nucleus will get destroyed. You will have protons and neutrons uh, going in opposite directions. Okay. The nucleus has been destroyed. Understood?
Yes, sir.
And then what you can do, you can isolate the protons from the neutrons uh, because protons can bend in a magnetic field. You can put a magnetic field, you can isolate the protons from the neutrons. So then you have a beam of protons, correct?
Yes, sir.
And then maybe you can just I don't know, but they are going up in opposite direction. Maybe you
opposite
can.
direction yes, maybe.
But how
There
can
are
you
chances to-
but you cannot bend them, right? But yeah, we get the signal of neutrons in our detectors. You can maybe you can put a target. You can have a beam target collision, right?
Yes, sir.
You can
Sir,
put a-
प्रोटॉन कोलाइडर में हम एक सिंगल प्रोटॉन को एक्सेलरेट कराते हैं या एक बीम को कराते हैं
bunches. There are
या
bunches.
पूरे न्यूक्लियस
No,
या
no,
पूरे
no.
न्यूक्लियस को कराते
No,
हैं
not the nucleus. We take hydrogen atoms, okay?
ओके
By applying electric field, we strip off the electrons. So whatever left is proton, right? Then we accelerate the bunch. So it's a hydrogen gas, okay? So it's a
Okay.
bunch of protons. It's not just a single
Okay.
proton. You cannot monitor a single proton.
मीन्स एच पॉजिटिव
Yeah, it's a H positive. Yeah. Also, when you collide lead nucleus, it's not a single lead nucleus. There are bunches of nucleus that are moving around and colliding. So I think in case of proton, there are 10 to the power 11 protons colliding each second at LHC. Okay. And so you can imagine how many collisions are happening every second. And
Yes.
so then what happened? So the detectors like CMS, CMS detector, right? CMS Atlas, the detectors at LHC. So these
Yes,
are
yes.
like a very high resolution cameras. Okay, they capture the events, all the events. So suppose two bunches are coming and colliding. Okay, what these
Yes, sir.
detectors do is they can identify each of those collisions where they were happening. Okay, and they can remove the duplicate collisions. So suppose one proton collided with other one, and then that again collided with low energy with other one, so it can remove those false collisions, you can say. You can get the pure.
बट सर ये ज्यादा मतलब ऐसे ही हाइपोथेटिकल बात कर रहा हूँ सर ये ज्यादा अच्छा नहीं होगा कि हम एक सिंगल प्रोटॉन को ही मतलब दो प्रोटॉन लेके हम ऑपोजिट डायरेक्शन पे उनको एक्सेलरेट कराएं और उनको हेड ऑन कोलिजन कराएं इज इट पॉसिबल और
Single proton, how will you get a single proton? It's very and you cannot be sure that they will collide, right? You have
yes.
to focus the beam. You need a beam so that you can focus the beam using the magnetic field.
प्रोबेबिलिटी बढ़ जाएगी कोलिजन
Obviously, it's all about probability.
यस
It's all about the cross section, luminosity. So these things matter. You need beam of particles, bunches of particles. You cannot take just a single proton.
One more question related to Big Bang theory.
Okay.
Sir, if the origin of the universe is Big Bang, then what was before that?
What?
What was before the Big Bang?
So there are theories, but our current experimental observations cannot verify that. Okay, so whatever cannot be verified is not allowed to be discussed in the science. So yeah, maybe we should stick to after the Big Bang. I mean, then they will be having philosophical uh, discussion. What was before the Big Bang? So far, there is no evidence of before the Big Bang. So hi Tuba, can you hear me?
Yes, sir.
Okay. So uh, the thing is, very few people joined today. So Professor Pitambar sir has left, and Rajni ma'am is here. So if you have any doubts regarding the live session, regarding the NPTEL lectures, you can put that in the chat box, and Rajni ma'am will answer it in few minutes. Okay, she will be back. She is uh, currently she has put her, I mean muted herself. But you can ask your questions or any general doubt you have in the chat. Okay. Hello, Tuba. Can you hear me?
Hello.
Yeah, yeah. So you understood, right?
Yes, yes, sir.
So yeah, if you have any doubts regarding the lectures, you can ask.
No, sir, not at all. Not yet,
Oh,
actually.
not it. Okay. So I mean everything is fine. You and any problems in doing the tutorial assignments?
No, sir, actually, we discussed it in class, so that's why.
Oh, so you discuss in your like class in the college, right?
Yes, sir.
Oh, okay, nice. So we have another participant here, Abu Bakr. He is also having the same thing in his college. So it's a good
Sir,
thing.
we are classmates.
Oh, oh, you guys are classmates. Okay, that's very good. Yeah. Okay. Nice. So, so every one of you have this is mandatory to take this course. Like it's mandatory from the university side, or you
So
guys are.
actually, this is a credit transfer course.
Oh, okay. You get credits for doing this course.
Yes, sir.
Oh, that's nice. Okay. So you guys will be registering for the exams also, right?
Sorry?
You guys will be registering for the exams. I mean, you will give the exams and certificates.
Yes, sir, we have already registered for exams.
Okay, that's good. Yeah, so we were discussing with Abu here some physics, interesting physics questions. So yeah, if you have also something to ask, you can ask here other
Sir,
than
I
the
just
lectures.
went,
Yeah.
today I just went through a news that they have discovered some demon particle. Do you have
What?
any idea about it?
Demon particle?
Demon particle, they have nicknamed it. Yes, sir. Like
Uh,
it's a electron, but they have the weird sort of interactions, so that's why they have named it demon.
wow. I have no idea. I have to see the news article. I don't know. So where did they discovered it? At LHC?
I don't remember the place exactly. It was just kind of physics breakthrough kind of thing. So it was in highlights today.
Oh, I don't know. Demon particle. So we had a god particle. Now we have a demon particle. Oh, that's
Yes,
nice.
sir.
Uh, I don't know. Yeah, I can see. I just did a Google search and I can see some articles. But yeah, okay. Maybe I'll have to read about it. Wow. So yeah, so far I had no idea we have no demon particle between us. But these names are just um, just to make it popular among the people. So the God particle, it was not, it has nothing to do with God or anything. Okay, it's just a particle, just a fundamental particle. So yeah. So you guys are doing MSc in your last semester. You are in your last semester of MSc, right?
No, so we are in third semester.
Oh, in third semester. Okay. So you are doing some projects, some thesis projects, or just they're just lectures.
Yes, so we have been assigned the dissertation topics. We are working on them.
Okay. What are your topics? Both of you, if you can.
My topic is rotation of Bose-Einstein condensation.
Oh, interesting. Uh, Rotation of Bose-Einstein condensate. So rotation in what sense? Like in how do you rotate it?
So the topic is just assigned.
Huh?
I didn't. The topic is just assigned. I didn't read up about it more.
Okay, okay. Oh, so you didn't choose it. You just got it, right?
There was a list, and we can choose from the list only.
Okay, okay. Yeah. So now you will read about it and get to know what it is.
Yes, sir.
Nice.
I just read about Bose-Einstein condensate.
Mm-hmm. So
No, I
you
will
understood
further-
what is Bose-Einstein condensate is?
Yeah, sir. Yeah, I understood.
Can you explain to us if you want?
Yes, I will try.
Yeah, sure. There is no pressure. I'm not grading you, so feel free. Yeah. Because I also forgot it.
may I explain it in bilanguage Hindi plus English?
Yeah, sure. Any language you want.
Yes. सर इनिशियली हमारे पास में थ्री स्टेट्स ऑफ मैटर थी जिसमें सॉलिड लिक्विड एंड गैस बट हमने देखा कि अगर हम टेम्परेचर को बढ़ाते हैं और बहुत ही ज़्यादा बढ़ाते हैं लाइक टेम्परेचर ऑफ द सन कोर ऑफ द सन और लाइक एट द टाइम ऑफ थंडर स्टॉर्म लाइटनिंग जब होती है उस वक्त जब टेम्परेचर हाईली इंक्रीज होता है तो वहाँ पे एक आयनाइजेशन हो जाती है मैटर की एंड हमारे पास आती है फिर एक फोर्थ स्टेट दैट इज प्लाज्मा स्टेट. This is if we increase the temperature.
So
but
what is plasma?
I
mean, what constitute the plasma?
Plasma is the ionization state of air. If air is ionized, then our state is formed. That called plasma state.
So basically, ionization means the electrons are ripped off from the atom, and electrons and nucleus are in a kind of in a soup, right? Which is called plasma, right?
Yes, sir.
Sure. Okay.
And if we lower down the temperature of a substance, then it becomes liquid, then solid. And if we further decrease the temperature, then the state is reached, which is Bose-Einstein condensation at very low temperature. At that temperature, the
So you're saying
पार्टिकल्स अलग अलग ना रह के एक कंबाइंड स्टेट में आ जाते हैं. मतलब जैसे हमने देखा है कि जैसे गैसेस स्टेट में मॉलिक्यूल्स जो होते हैं वो दूर दूर होते हैं, थोड़ा लिक्विड में थोड़ा पास होते हैं, सॉलिड में और भी ज्यादा पास हो जाते हैं. लेकिन एट बोस-आइंस्टाइन कंडेंसेशन में इतने पास हो जाते हैं कि वो अपनी इंडिविजुअलिटी लूज कर देते हैं और एक सिंगल टाइप ऑफ चीज बन जाते हैं.
okay.
तो उसको फिर हमने बोस-आइंस्टाइन कंडेंसेशन.
So you're saying any matter we can take, and if you lower the temperature, it will be changed into a Bose-Einstein condensate?
No, I'm not sure about any matter, but
What is the criteria of
actually, it was a theoretical interpretation before. But in 1995, there were two scientists. I exactly forgot the name. उन्होंने रुबीडियम को लिया था और रुबीडियम पे उन्होंने इस एक्सपेरिमेंट को इस थ्योरी को एक्सप्लेन किया है एक्सपेरिमेंटली इन 1995 में। रुबीडियम को उन्होंने लिया और उन्होंने इस चीज को टेम्परेचर को लोअर डाउन किया उन्होंने विद द हेल्प ऑफ लेजर।
How can you lower down the temperature using a laser?
बिकॉज लाइक सर जैसे हमारे पास दो एक्चुअली उन्होंने स्टडी किया कि लोअर टेम्परेचर पे एक्चुअल में होता क्या है। जैसे जैसे हम टेम्परेचर को घटाते हैं तो जो पार्टिकल का मूवमेंट होता है वो स्लो डाउन हो जाता है। ठीक, तो अगर उन्होंने ऐसे तो उन्होंने क्या किया कि सपोज हमारे पास अगर हमारे पास उन्होंने एग्जांपल लिया कि सपोज हमारे पास दो बॉल्स हैं और हम उनको ऑपोजिट साइड में एनर्जी देते हैं, काइनेटिक एनर्जी ऑपोजिट डायरेक्शन में, और उनका हेड ऑन कोलिजन करते हैं, तो क्या होगा कि दोनों की दोनों अपनी एनर्जी लूज करेंगे और रुक जाएंगे। तो उन्होंने क्या किया है कि लेजर को उस जिस मैटर को भी हमने कूल डाउन करना है उसको उन्होंने ऑपोजिट डायरेक्शन से डिफरेंट डायरेक्शन से उसके ऊपर लेजर लाइट को एक तरह से फोटोन को उन्होंने बम्बार्डिंग कराई है और जो पार्टिकल्स का मोशन था उसको स्लो डाउन किया। और जब पार्टिकल का मोशन स्लो डाउन हुआ तो वो एक तरह से उनका मोशन फ्रीज हुआ। दैट इज द रिक्वायर्ड जो हमें मतलब उनका मोशन जब स्लो डाउन हो वही तो कंडीशन होती है जिस पे जाकर टेम्परेचर मतलब जो लोअर टेम्परेचर पे होती है उसका टेम्परेचर फिर स्लो हुआ। एंड ये चीज इसमें एक्चुअली यहाँ अर्थ पे इस एक्सपेरिमेंट को करने में प्रॉब्लम ये है कि पार्टिकल को सस्पेंड करना बहुत मुश्किल है बिकॉज ऑफ द ग्रेविटी। बट आई फॉरगॉट द ईयर जिसमें नासा ने इस चीज को जाके जो हमारा इंटरनेशनल स्पेस स्टेशन है उसमें वहाँ पे क्योंकि ग्रेविटी का इफेक्ट कम है तो वहाँ पे इसको जब उन्होंने किया तो वहाँ पे ज्यादा इजीली इस चीज को कर पाए। बट यू आर राइट, लेजर तो हीट बढ़ाता है बट ये हीट को तो लेजर के हेल्प से कैसे कूल डाउन किया है बिकॉज वो एक प्रॉपर फेज में एक प्रॉपर एंगल पे उन्होंने उस चीज को चारों तरफ से उसको उस तरह से लिया।
Maybe the femtosecond lasers can do that. I'm not sure, but I know that the femtosecond lasers have the ability to change the dynamics of the atoms inside the matter, but I'll have to read. I'm not. Yeah.
femto laser.
Yeah.
femto laser बताया आप?
Femtosecond lasers. Yeah. You know about it? They're very high energy lasers. Yeah. Okay. That's nice, but you know that liquid helium can be cooled down and around at 3 Kelvin it becomes a super fluid, right?
Yes, sir.
And then you can get a Bose-Einstein condensation. Yeah, it's a very interesting state of matter. So all the particles acquire a single energy level, right? I mean, they are all in the same energy
Yes,
level.
sir.
They move collectively. So the I was discussing about this heavy ion collision, okay, and the matter that get created in that collision is called quark-gluon plasma. Can you guess what it is? Like you have an ordinary plasma.
Can you please repeat?
Quark-gluon plasma.
No, sir, I don't know about it.
So you have this ordinary plasma, right? What is ordinary plasma? Atoms, electrons are ripped off from the ionized from the atoms, and you have nucleus and electrons, okay,
Okay, sir.
in a soup kind of thing. So similarly, when two heavy nucleus collides, okay, what happens is, because there is so much energy and it's a very dense, the system becomes so dense, so that the individuality of each protons and neutrons get destroyed, okay. The quarks that are there inside the neutrons and protons, they are free to move in a larger volume, okay. So that state of matter we call quark gluon plasma. And it's also very interesting matter. It is the most perfect liquid. So you know that the superfluid are called more perfect liquid, but it's more perfect than the superfluids because it has very low viscosity in terms of hydrodynamics, and yeah, it flows better than any known liquid. uh, so yeah, we studied those properties, and we have found that the quark gluon plasma is the most perfect liquid ever produced. So
Most perfect liquid means what extra they have?
so like I said, so what is the which liquid you call an ideal liquid, a perfect liquid, which has a very low viscosity, which flows without any resistance, right?
Yeah. Yes,
but
sir.
but that is not the only requirement. You need viscosity. So for example, can you tell me which is a better fluid, air or water? Which has low viscosity, air or water?
Viscosity, air.
Air has low viscosity, correct, but water is a better fluid than air. Do you know why?
Yes, sir. Yes, because the influence of gravity is more on
No
water.
gravity. Why do you need gravity? It is because the relative viscosity, the viscosity by density, okay. When you plot viscosity by density, compare air and water, water has low viscosity by density ratio. So that's why water is a better fluid than air. And because this quark gluon plasma is a, it's a very because you are going at a Planck scale, right? Near you cannot define density there as you define for water or air, okay. So what you can define is, you can define entropy density, okay, disorderness. And so it's a relativistic quantity. So for example, you know relativity, right? For every classical quantity you have a relativistic term.
Yes, sir.
So for
Yes, sir.
density you get entropy density, okay. So when you compare viscosity by entropy density of quark gluon plasma with all the known matters, you find it the lowest. So that's why we call it most perfect liquid. And not only that, it is the most vortical liquid also. Vorticity, you know, right?
Sorry?
Vorticity, you know vorticity, the angular momentum of so suppose water, you take a water and you rotate it, there is a
Yes, sir. Yes, sir.
vorticity.
Yes, sir. Yes, sir.
So yeah.
Yes, sir.
So it is the most vertical liquid also, because see, when nucleus collide,
Yes, sir.
it imparts its angular momentum in that quark gluon plasma, and so it's really very fast rotating, and it's very vertical. So it's a very interesting.
Sir, may I ask, आप IIT में प्रोफेसर हैं?
No, I'm a PhD student.
स्टूडेंट, ओके सर। हमारी यूनिवर्सिटी में ये जो हम ये थीसिस लिखेंगे, जो भी हम ये लिखेंगे ना, जो हमें डिसर्टेशन के लिए मिला है, तो हमें ये अलाउ करते हैं कि हम अगर किसी बाहर के प्रोफेसर के अंडर काम करना चाहें, सपोज IIT के किसी या किसी और यूनिवर्सिटी के, तो हमें परमिशन होती है कि हम बाहर से भी अपना टॉपिक चूज करके कर सकते हैं।
sure.
बड़ा पर्सनल चीज पूछ रहा हूँ मैं इंटरनेशनल प्लेटफॉर्म पे, बिकॉज हम दो ही हैं यहाँ पे। सर, इज इट बिकॉज मैं आपसे कनेक्ट नहीं कर पाऊंगा किसी और दूसरी जगह पे? सर इज इट पॉसिबल कि मैं किसी IITN के अंडर अपना ये डिसर्टेशन वर्क कर लूँ इफ यू नो इफ एनीबडी इंटरेस्टेड
Yeah. You can. So yeah, you can mail professors here directly. Okay, and you
आई
just.
डोंट
Mm-hmm.
कैन यू प्लीज गिव मी द ईमेल आईडी
Email ID you can find that. So for IIT Madras, so you just go to. I'm sending you the website. Okay, physics.iitm.ac.in. You go to this website, and you can
Okay, sir.
find the list of all the faculties there. Okay, and if you think that you are interested in someone, and every topic is also mentioned, whatever topic they are working on, they are interested in. Okay, and
sir, okay.
if you think you are interested in some topic, you can just directly mail them, sir, I want to do a project under you, and because they don't have to pay you anything, right?
Yeah, of course.
Yeah, then I don't think there will be much issue. You can just join a joint project or something under them. It's I think it will be. It just depends on the professors. Like, if you can send them your
Okay.
CV or and your transcripts and all, and yeah.
आप गेट के थ्रू सर आप PhD में एडमिशन लिए हैं
Not through GATE. So I did my masters from IIT Kharagpur.
विद जैम
Yeah, and then so I got transferred here. I had an interview from here, and so. So you are interested in doing PhD, or?
यस सर आई एम इंटरेस्टेड इन डूइंग PhD
Okay. Yeah, I mean,
I also मैं भी इंटरेस्टेड हूँ सर IIT से PhD करने में और मैंने जैम का एग्जाम भी दिया था
okay.
बट आई डिडंट स्कोर दैट मच
Okay. No,
बट यहाँ पे भी
but
जो
you can
प्रोफेसर्स
for
हैं
PhD.
बहुत अच्छे हैं बाकी यूनिवर्सिटीज से
हाँ,
जो यहाँ हमारी यूनिवर्सिटी में प्रोफेसर्स हैं बहुत अच्छे से पढ़ाते हैं
So it depends. So it doesn't matter IIT or any university. Okay, what matters is if you have, correct. If you have all the equipments. If you are going to do suppose something in some experimental physics work. Okay, then you need some equipments to do your studies, right? So if
Yes,
you
sir.
have those equipments in your university, you can do your PhD from there too. You don't need IIT, because see, at the end, it is the guide and the experimental lab that matters, not the institute, right? So
यस
yeah, so I think what you should look for is a proper lab in a proper institutes. Okay, institute. If you have, and you need to be clear about your research interests. What you want to do in your PhD. So that's why these projects are there in the masters, right? They help you explore the topics in more
व्हाट्स
detail.
योर टॉपिक सर व्हाट इज योर
So-
एरिया ऑफ रिसर्च
So my area of research is high energy physics. Like I said, I work in collaboration with CMS experiment at CERN, and we study these heavy ion collisions. So we don't have any experimental facilities here at IIT Madras. We have to go there at CERN to to take part in the experimental activities and get the data from there, and so then we do our studies. Because it's a very large accelerator. Those kind of accelerator you cannot build in an institute or anywhere.
यस सर
It can only be built through collaborations of many.
Hello?
Yeah, ma'am.
Yeah, so did anyone else join? No.
Yeah,
Is he
so
only-
one student joined and she left, but she also hadn't any doubt.
Okay, okay.
So yeah, so far we are just having a general discussion, me and Abu
Okay.
Bakr. Yeah.
So I think it is unlikely that anyone will join now. What do you say? People join after 1 hour or so?
I don't know if now if anyone will join because it's already 1 hour
More
past.
than five. Yeah, more than 1 hour has passed.
Yeah. So,
Okay.
ma'am, if you want to leave, you can go.
Okay.
I'll be here for a while, and then
Okay.
yeah,
Okay.
maybe I'll see
So
you
I'll,
next
I'll,
week.
I'll mail you about next week if I'm traveling or
Yeah,
something.
ma'am.
I'll
Please
just
inform me about the next week so that I can be prepared for the next session.
Okay, okay, I'll mail you. After that, mostly I will be
Okay,
there.
okay, ma'am.
For
Sure, sure, sure. There is
maybe
no,
2 weeks
issue.
after that, I will be
Okay, okay, ma'am.
there. Okay.
Thank,
Okay, then. Bye.
thank you.
Thank you, ma'am. The next वीक मैं अपनी क्लास में अनाउंस करूंगा बहुत मे बी बहुत सारे स्टूडेंट्स पे पता भी ना हो और फिर नेक्स्ट वीक में भी ज़्यादा स्टूडेंट आएंगे और हम भी थोड़े अपने डाउट्स लेके आएंगे
Yeah, sure, sure, sure.
एक्चुअली दिस इज फर्स्ट टाइम आई एम हियर तो आई मुझे नहीं पता था कि एक्चुअली यहाँ पे किस तरह के डिस्कशंस
Yeah, this is for this is here we can discuss anything. We can discuss dots
Can you
about.
tell me about the actual weightage of quiz and the and term exam
For this course,
for this net tell? Yes, sir.
I'm not sure. I have because I'm not involved in the examination part of this course. Okay, I have my responsibility is just to conduct this session and clear any doubts or.
So will you be there next week?
Yeah, I'll be here every week. I
Please,
can inform you later about the weightage of the marks. Okay.
Yeah,
But I think
what
those
will be
things
the
are.
weightage of quiz? Actually ये हमारे सिलेबस का हिस्सा है और हमें एग्जाम भी देना पड़ेगा और उसका वो वेटेज सब वहाँ पे जाएगा.
But I think this information should be available at NPTEL website. Is it not there?
I think that is not proper. बस तो किया था.
Okay, then okay, I'll take a look and let you know next week. Okay.
Okay, sir.
Okay. But don't worry about too much about the exams. I think assignments are not that tough. You can easily do that, right? And exams will also be like that. If you have understood everything in the lectures, you will not face any issue. I think everyone can score good in this course. Just you have to go through the lectures very carefully, and we are here to help you if you don't understand anything. Correct?
Okay.
So okay, you have any more question?
No, sir. Next time we will.
Okay, yeah, sure. So when you go through the lectures, if you get any you don't understand anything, any part, you can just write it down and come here every Saturday 4 p.m. Okay,
Yes.
and we can
Yes,
have a discussion. Okay, I think someone has joined again. Prashanthi, can you hear me?
Yeah, I'm from NPTEL team.
Oh, okay, ma'am. Hi.
Yeah.
So, yeah, ma'am. I mean, only one student joined today, so we are just having some general discussion. I asked about the dots, if he has any dots, and there were some dots, and some questions he has, and we discussed that. So, yeah, I mean, this session is for 2 hours, but yeah, I don't know. So, Abu Bakr, do you have any more? You don't have any dots for now, right?
No, sir.
Okay.
Next.
So what we can do is maybe we can join again next week. Maybe you can join again next week with some doubts or questions. Okay, and
Yes.
we will try to answer them. Right?
Yeah, sure.
Okay. So okay, just okay. Let's close this for today,
Okay.
and see
Yes.
you next time. Okay.
Yes, sir.
Okay.
Thank you so much, sir.
Thank. Bye.